Hi there, and in this short video we're going to show you how to use the examples that come with PTP Sequencer. So what we have here is a version of LabVIEW 2013 with PTP Sequencer already installed. To get to the examples, the best way is to open up the NI Example Finder from the Help menu. So go to Help, Find Examples, and in the NI Example Finder we're going to do a search for Sequencer, and this will find the PTP Sequencer examples. Let's start with drag and drop editing, and this example is particularly good at showing you the included X controls that you can use on your front panel for quick and easy creation and manipulation of your sequences. So I'm just going to run this VI, and you can see what we have on the left here is a list, and this includes some tests. I'll show you how we create that on the block diagram in a minute. And on the right here we have our tree view, which represents our sequence. Currently we have nothing in here, so this is an empty sequence. So with the drag and drop functionality, we're able to simply select and drag and build up a sequence of tests, and we can manipulate these around and move them around within the sequence just like that. And of course we can have any number of these in here. Also, let's have a look at some loops. So we have a customized right click menu here in the tree view, so I can right click and suggest that we create a new loop. We have ourselves here a new loop with nothing in it, so let's start putting a few things inside that loop. So we can add some tests in here. We can even move around tests that exist within the sequence itself, put them within that. And we can also configure this loop. So if we right click, again we have a customized menu, we can select loop, configure, and we get this panel, and we can give this loop a name, and we can tell it how many times we want the loop to actually iterate, and we now have a loop which will iterate 3 times. And of course we can have nested loops, and I'll also demonstrate another technique for creating loops here. You can actually multi-select some of your tests, right click and wrap with the loop. So now we have 2 loops. We can configure the inner one, call this one the inner loop, run this one twice, and of course we can drag and drop our loops around as well if we wish, and we could actually reverse the order of the loops there and put the inner one on the outside. Okay, so that's a good example of how we can use the X controls for quick and simple manipulation of sequences. Now if I have a look at the block diagram for this, you can see that it's very small. There isn't very much to do. In the first block here that I've highlighted, we are simply creating 4 mock tests. These files don't exist, but it doesn't matter for the purposes of this example. So I'm creating path style tests where a test simply points to a VI, and I'm building up an array of these and pushing them into the tests list X control, and it will display them as it's done and make them available for drag and drop. The second X control is this one here, which is our sequencer tree, and as you can see on the block diagram, there is no code associated with that terminal whatsoever, and all of the functionality that the tree presents us with that allows us to drag and drop and manipulate and create loops is all built into the X control. So you don't need to worry about creating any of your own code to handle any of that. It's all built in. And this event structure here is simply there to capture the close event when you click the cross in the right hand corner, which I like to use for terminating my examples. So there you can see that this X control, both these X controls give you great power for building sophisticated user interfaces, and you don't need to worry about the code that's required to handle that. So now let's take a look at another example. We'll go back to NI Example Finder, and we'll launch the sequence execution example. So this example shows you how PTP Sequencer will execute through your defined sequence, and how you can programmatically call that and retrieve the information from it as it executes. So this is the front panel, and we have on here the tree view again, same as the drag and drop example, and I'll show you the block diagram for this. It's fairly small, the first thing we do is we load a predefined sequence from file. So this function here is our load sequence function. The sequence is provided here on this terminal, and the first thing we do is we pass it into our sequence tree, and this X control will then display that sequence. We also call the reset sequence function. Reset sequence simply, as it says, resets the sequence in preparation for execution. And then in this while loop here, we actually perform on a 1 second counter execution of the sequence with this next function. So all that next does is it calls upon the sequence a request for the next test in the list, and this of course will obey any defined loops that you might have in your sequence. And the test comes out on this terminal here, so we call this the sequence element, and the sequence element is passed into this function, which will extract the path that the test is pointing to. It will extract the definition or the description of that sequence. And also here actually we're also using the arrayed value, and we'll get onto that later. We also use the sequence complete flag to work out whether or not this sequence is completed, and if it has, then we terminate the while loop. So let's go ahead and run this. And what you'll see there is that we've loaded a sequence from file, and while it executes, we have highlighting of the test that is currently being executed. And it's not a very long sequence, and it's already complete there, so I'll run it again. And while it's running, you can also see that the information that we're pulling out regarding the path and the description is updated on these indicators here. So the automatic highlighting is something that you can turn on or off within the X control view. It's not something you need to have to worry about. It's all handled in the background by the X controls and the engine itself, and we can change the performance of this view here. So we're back into edit mode because the run is completed, and if we right click the X control, you see we get this properties box, and this allows us to define precisely how our X control will behave. So you can see that the only features on at the minute are navigation highlighting and the vertical scroll bar. So we can change the color of the highlighting, and we can also turn on the editing. And in the drag and drop example, some of these features indeed were on. So the allow drag and drop was on, and the right click context menu is on. So just to demonstrate that I've changed the color of the highlighting here, I'm going to run that again, and now we have green highlighting. So now we'll take a look at some programmatic editing of sequences. So back in the back in the example finder, we'll launch Programmatic Editing, and this example provides you with code snippets for some of the functions within PTP Sequencer. So we'll go ahead and run this, and we have a selection list which briefly describe some of the functions that you can perform in PTP Sequencer programmatically. For example, we can ask for the demonstration on how to create a loop. So if I run show demo, what we get on the right hand side is a snippet of the block diagram that's been executed that demonstrates how to create a loop in PTP Sequencer, and on the left here the actual result of that execution with some description below. So you can see that we created a new sequence called loop example, and we created a new loop called my loop with 4 iterations. In that loop we inserted two tests, my test 1 and my test 2, and then we insert that loop into the sequence, and indeed you can see that definition there. And we can look at some of the other examples, such as setting the execution status, or indeed getting the sequence as a flattened list, which is something you might want to do. Now we have one example left, and that is an example project. So we'll go ahead and launch this project, and this is a very simple test executive demonstration. So this is included of course with PTP Sequencer, and you can see here from the project view that we have one main VI, this is our parent VI, and I'll call this in a second, and then we have some virtualized folders, and in here we have some of the classes that I use for the messaging structure, some of the sub VIs that make up part of the architecture, a folder of tests. So we actually have some test VIs here that will be called and demonstrated, and this includes a test template. So if you do go ahead and use this, this project, then you can use this test template to create your own tests that are compatible with the architecture I've designed here. And we have some type-defined structures in there. So I go ahead and launch main.vi. So this is a simplified representation of a simple test executive. We have a toolbar across the top with a series of buttons. We have our test sequence view here. We have our tests list, and on the right hand side this is a subpanel within which the tests will actually be inserted. So I'm going to go ahead and load a predefined sequence from our sequences folder, and we have the same temperature loop that you will have seen in the sequence execution demonstration, and I can go ahead and run this. And again, we've got highlight execution, and the tests are loaded and inserted into this subpanel on the right hand side. And as this runs through, we can interrupt this at any time. So I'll click stop, and we see that the sequence has been interrupted. And then if we wish, we can continue the sequence, moving on to the next test and the next test, and I can click stop again, and as soon as this test is complete, the sequence will pause. So what we can also do is, using the editing functions, is we can modify this. So I might rearrange these tests, and I've now moved power spectrum before the measure supply voltage. We might then save this as a different sequence, so all the saving and loading is built into the toolkit, so you don't have to worry about that yourself. So I'll just call this new sequence. Reset this, run it again. And something that's also used here is the arrayed data values. So this test is running to 10 degrees C, and when this loop iterates round, we can see that the set environment temperature test will actually aim for a different temperature. So we come back around, and now it's aiming for 25 degrees C. And what that is that's following the use of built-in. So if I actually configure this loop and have a look, you see that we have auto-indexing value arrays, and there is one defined as temperature, and in here we have three temperatures, 10, 25 and 40. And we can go ahead and alter the values for these to whatever we wish. We can add another one and make this a 4 iteration loop. Select OK, reset this sequence and run it again. And you'll see now that the first temperature it aims for is 5 degrees, which was the first value that we entered into the value array. So I'll go ahead and stop the sequence again. And of course, with the drag and drop example, we can modify this. We can introduce new tests, or we can select one, right click and delete to remove. So let's go ahead and have a look at the block diagram for this. It's relatively small. We're using a producer-consumer loop, and if you're familiar with any of National Instruments' promoted architectures, you'll have come across this before. I won't go into too much detail, but we have an initialization VI, followed by two loops, the producer and the consumer loop. The producer loop is responsible for generating tasks or jobs which are sent through an event, a queue to the consumer loop, and the consumer will receive those and execute them within this. Now I'm using a class-based factory pattern, which allows this to be a very extensible architecture, and you can build on this and introduce your own class children to introduce your own jobs to this architecture. It's very flexible. Now, if you decide you wish to use this as a template to build on, then I recommend that you make a duplicate copy of this project so that you're not editing the included example files. So the simplest way to do that is right-click the project, click Save As, Duplicate, and we need to select the contents that we wish to duplicate. Click Continue. And from this list we need to deselect the dependencies, because these are all part of the VI library and we don't wish to be copying those. However, you can leave everything else selected, and that will ensure that we get copies of all of that. We can then go ahead and create a new folder somewhere called My Test Executive, and a duplicate of the project will be created in there. And if we go ahead and take a look, indeed we have our own LabVIEW project in here, and this will represent up your copy of the project.